Hi, so for my final project, I decided to y- try to classify letters rather than the number classification example that we had in class. So I'm doing this by loading a dataset by MNES. They do have a letters dataset right here with these many example characters and with 26 balanced classes, which is there's one letter for each class uh, in the English alphabet. So after I downloaded this data set, then I um, loaded the data set using one of the helper functions, and it looked like this. They already separated the data set into training and tests for me, so that was nice. I reshaped the data a little bit so that it will work with our model. I normalized the values so that the values are between 0 and 1. And then what I did was I was just playing with the data to see what an example input would look like. So I printed out a 2 by 2 grid of what this input would look like, and this looks like an E. And I printed out the Y value, which is 5, and the corresponding letter. So it's 5 because A is 1, B is 2, C is 3, 4 is D, and 5 is E. So the Y output is actually one index rather than 0 index. Because it's one index, I have to subtract 1 to make sure it matches with our, I guess it's required for some of these keras functions. So, let's see. This is my model. This is the same model as one of our examples. I think it was the Linet 5. And I started training it, and each epoch took about, let's see, 3 minutes. And as you can see, the validation accuracy is keep on it's always increasing, so that's a good thing. It didn't really overfit on any specific epoch, so I think if I increase the number of epochs, the I should see better results from my model. But I decided not to do that because it's too late for that. So I saved the model into this file because I plan to use it in the future. And then I was just playing around with one of the outputs again to see what the expected value is. I guess this is not really necessary, but yeah. So that whenever I predict a value, it will give me for each index, for each letter, it'll give me how confident it believes that index is. So this is just a function to just extract the best index so far. And in this case, this example, the best index is 25. So with the 99.99% confidence, it believes that this letter is Z. Um, so on top of this, I wanted to see what other how if I were to like put inputs into this model, how it would behave. So I created a small app where it lets me draw a letter, and then it will guess that letter. So let me try drawing X. So I drew this dash and I thought it's a Y. Um, and then after I draw this, it thinks it's an X. So that's good. The way this works is that this grid is about 728 by 728. So I do have to downsample using max pooling. And the data is actually a bit different from the actual handwritten data because it's binary data. So all the values it could exist is 0 and 1, whereas the handwritten drawings were grayscale values that could range between 0 and 1. So it could be any values between 0 and 1, whereas my examples it's always 0 or 1. So because of that, this this doesn't really match the data set, so I can see how some of these guesses could be incorrect. So let me try another one. Oh, so this is guess is a Q. So let me try it again. Okay, great. It guessed it correctly this time. Let me try one last one, which is a T. It already guessed that it's a T, but yep. Great. Awesome. That's it. Don't forget to comment, like, and subscribe to this video.